So here's a fascinating question for you. Can an AI, a machine learning model, actually do a better job than a human expert at one of the most basic yet crucial jobs in all of agriculture, figuring out if a piece of fruit is perfect for the market? Let's find out.
Okay, look at these. To our eyes, the difference seems pretty obvious, right? We see a raw one, a ripe one, and a defective one. But you have to remember, for an AI, this is just a giant, messy puzzle of pixels, colors, and textures. The real challenge is teaching a machine not just to see those pixels, but to actually understand what they mean.
And trust me, this is not just some fun academic experiment. For farmers, especially in places like Vietnam and Bangladesh, where dragon fruit is a huge deal, this is a very, very high-stakes problem. I mean, here's the core of it, the risk. When you're inspecting fruit by hand, people get tired, they make mistakes, and all it takes is a few bad, misclassified fruits sneaking into an export container to cause rot, spoil the whole batch, and boom, a quality check fails. That's a massive financial hit for the farmer. And we're not talking small potatoes here. The scale is just colossal. In Vietnam alone, the annual harvest is over 1 million metric tons. When you're dealing with that kind of volume, you can see why having an automated, super accurate grading system isn't just a nice to have, it's an absolute necessity. Now, here's what's really wild about this, and it all comes down to biology. Dragon fruit is what scientists call non-climacteric. So unlike a banana that gets riper on your counter, a dragon fruit stops ripening the second you pick it. That means the decision you make at harvest is it. It's final. There are no second chances. You either get it right on the vine or you don't get it right at all. So how in the world do you build an AI that can handle that kind of pressure? Well, the researchers behind this study knew the secret wasn't just about writing a smarter algorithm. Now, the foundation of any truly great AI is truly great data. So they came up with this brilliant 5-step plan. First, you clean the data. Then you upgrade its quality. After that, you hold a competition, an AI bake-off, to see which model performs best. Then, you create a new hybrid champion. And finally, you audit the whole system to make absolutely sure you can trust its decisions. That first step, the data purity audit, is so important. They used a cool technique called MD5 hashing. The best way to think about it is like creating a unique digital fingerprint for every single image. This let them hunt down and delete 44 duplicate photos. Why? Because it stops the AI from just memorizing pictures to cheat on its test. It forces it to learn the real biological signs. And this is how they got the AI ready for the chaos of a real farm. They took all that clean data and then they messed with it. On purpose. They started digitally flipping, rotating, and changing the brightness on thousands of images. This whole process trains the model to be tough, to be resilient, so it doesn't get thrown off by a shadow in the evening or the bright glare of the midday sun. Okay, so with this rock-solid dataset ready to go, it was time to build the machine's eye. And this, right here, is where the real breakthrough happens. The researchers came up with a brand new, hybrid way for an AI to see the world. Think of it like this. Traditional AIs, called CNNs, kind of see an image by scanning it through a tiny little window, focusing on small local details like the texture of one little scale on the fruit. But this new approach, a vision transformer, it's totally different. It chops the image into a grid and looks at all the pieces at once, understanding the big picture, how the color on the bottom relates to the shape at the top. It sees the whole fruit. But they didn't even stop there. They put together the ultimate team-up, the hybrid VIT-SVM model. It's genius. It uses the powerful context-aware eyes of the vision transformer to look at the fruit and pull out all the important features. Then, it hands that info over to a classic, super efficient classifier called an SVM to make the final, sharp, decisive call: raw, ripe, or defective. So, that all sounds great on paper, right? A clean data set, a powerful new way of seeing, a cool hybrid design. But did it actually work? Well, let's take a look at the results. So the researchers held that AI bake-off, putting their new hybrid model up against some older, well-known AIs like ResNet 50 and DenseNet 201. And as you can see from the numbers, it wasn't even a contest. The other models did okay, hitting around 99.5%, but the hybrid VIT-SVM system was just basically perfect on every single measurement. And what it all boils down to is this one incredible number. The final model clocked in with an accuracy of 99.84%. That is a level of consistency that's pretty much impossible for a person to maintain, day after day, hour after hour.
But listen, that 99.84% is meaningless if we don't know why the AI is so good. And this is the part that blows my mind. Using a technique called attention mapping, we can literally see the AI's thought process. This heat map shows us that to judge a ripe fruit, the AI is focusing on the deep magenta color spread across the body. That's the exact biological sign a human expert would look for.
And look at this. You can see how smart it is. When it looks at a raw fruit, its attention totally shifts. Now it's zeroed in on the green tips of the scales, which is the #1 indicator that the fruit isn't mature yet. This isn't some black box that's just guessing. It's an explainable system that actually learned the botany of the fruit. We can see its work. So, yeah, this research is obviously a game changer for the dragon fruit industry, but the implications here are so much bigger. This is really about the future of farming itself. So let's just recap why this is such a big deal. First, you've gotten your perfect accuracy, which means way less financial risk for growers. Second, and this might be the most important part, this transparency builds trust. A human inspector can actually see why the AI made a call, making it a reliable partner. And finally, the whole system, from cleaning the data to the hybrid model, is scalable. You could adapt this for grading apples, spotting diseases on wheat, you name it.
And that leads us to the final big question. We started off asking if AI could grade fruit better than a human. This research seems to scream yes. So the real question we're left with is this. If a transparent, trustworthy AI can master something this subtle and complex, what other industries, from spotting tumors in medical scans to checking for defects in a factory, is it ready to transform next?